Question number 4. We're asked to solve the system. This time we've got 3 equations with 3 variables. However, if we look at the third equation, we notice that it's only got the x and the z. And I also notice that x has a coefficient of 1. So that's going to make it easy to solve this equation for x. So I'm going to write this. I'm going to subtract 5z on both sides. So it'll be x equals negative 5z minus 6. And then I'm going to substitute this into the other 2 equations in place of x. So I'm going to rewrite this as negative 2 times negative 5z minus 6 plus 3y plus 3z equals negative 6. Second equation, I'm going to say negative parentheses negative 5z minus 6 plus 2y plus 2z equals negative 1. So now I've got it down to 2 equations, and I've only got y and z to deal with. So let's distribute this negative 2. So it's going to be positive 10z plus 12 plus 3y plus 3z equal negative 6. Second equation will be positive 5z plus 6 plus 2y plus 2z equal negative 1. Okay, going back to the first equation, I need to combine like terms. I notice I've got z's are like terms. I'm going to start with 3y just because I like having them in alphabetical order. That's the only reason I started with y. Plus 13z. I want to subtract 12 on both sides, so I'm going to bring it over here and it'll become negative. So I'll have negative 6 minus 12 is negative 18 on the right side. Second equation, I'm going to start with 2y, and then 5z plus 2z is 7z. And I want to subtract 6 on both sides, so I'll bring it over here, it'll become a negative, and that'll give me negative 7 on the right. Okay. Now I want to eliminate one of these variables. So looking at the y's, they have coefficient of 3 and 2. So let's look. So the least common multiple of 3 and 2 is 6. So let's multiply the top by negative 2 and the bottom by negative 3. So that will become negative 6y minus 26z equal, and multiply this side as well, negative 2 times negative 18 is positive 36. And then in the bottom, I've got negative 6y. Oh, I'm sorry. I need to do a positive this time, not a negative, because I want opposite signs. So I'm going to have positive 6y. 3 times 7z is 21z. And 3 times negative 7 is negative 21. Now I'm ready to add them, because the y's are going to cancel. And then I've got negative 26z plus 21z is negative 5z. And 36 minus 21 is going to be 15. Now I can divide both sides by negative 5. And I've got z equals negative 3. So again, since I know that these types of equations do not lead to extraneous solutions, I want to go ahead and circle that. Then I'm going to back substitute to find my other variables. So we found earlier that we had x was equal to negative 5z minus 6. I'm going to substitute my negative 3 into that equation. So that will give me x equals negative 5 parentheses negative 3 minus 6. So that's negative 15. Oh, no, I'm sorry. That's positive 15 minus 6, which is 9. And then use my x and my z value to get my y value. So I'm going to go all the way to one of the original equations for the last part, and I'm going to substitute in my z and x values. So I'm going to say, I can't get it all on the screen, I don't think, but I'm going to say negative 2. I'm using my top equation. So negative 2 times 9 plus 3y plus 3 times negative 3 equals negative 6. Negative 18 plus 3y minus 9 equals negative 6. That's going to give me negative 27 plus 3y equals negative 6. Add 27 to both sides, so you'll have 3y equals positive 21. And divide by 3, y equals 7. So I got my ordered triple is going to be 9, 7, negative 3. So on my choices for this one, 9, 7, negative 3 is choice B.